Hello everyone, welcome to today's video. Today we're going to practice creating slots in Catia V5 Part Design workbench. So I'm going to attach a technical drawing on my Patreon page, and then the link is going to be in the description below. It's going to be free, don't worry. So just download it real quick and then come back here, and then let's proceed with the video. So we're going to start by creating this shaft. As you can see from this top profile, this is 6 millimeter in diameter, and it is also 80 millimeters in length. So we can select the XY plane and sketch. Then you're going to create a circular profile. And the diameter, now this is the radius. So if the diameter is 6, the radius is going to be 3. Then we're going to create a pad, which is going to be 80 millimeters, but I'm just going to extrude 20 on the upper side and 60 on the lower side. So I'm going to enter a second limit of 60 millimeters, like that, and select OK. All right. Then we're going to create the profile, this profile here. So its diameter is 10 millimeters, its length, I mean, and the width is 1 millimeters. Then we have an edge fillet of 2 millimeters on both the bottom and the top and the bottom profile, sorry. And it also has another fillet where it attached to the shaft of 1 millimeter radius. So I'm going to select the ZX plane. We can just use a rectangle like that. Then select both of this height and make them symmetrical about the vertical axis. Select symmetry. Then for the top part, it should be coincident with this surface. So coincidence. Then we can adjust the measurement. So this was 18 millimeters. And this is supposed to be 10. So 10, 5 on each side. I think that's good. Now this is in the middle. So when we are extruding, we're going to use mirrored extent and divide the length. So the length was 1 millimeter, so it's going to be 0.5 in each direction. So you can just select a pad with mirrored extent, and then the length is 0.5. Then we can apply the fillets. So for these 4 corners, the radius is 1. So select edge fillet and then enter 2 is the radius. No, that is 1, sorry. It's 1. And then for the top and bottom corners, that's where we have 2 as the radius. Once again, the edge fillet, and then this is 2 millimeters. So we are done with the top part. Now for a length of 60 millimeters from the bottom, that's where we have the winding, spiraling drill bit part or the slot. So we're going to create the profile. You need the profile and the center curve. So the profile is the one that is going to cut out the material, and then the center curve is that profile that is going to be spun or winded upon. So of course our center curve is going to be a helix, but because we're in the part design workbench, we're gonna need to switch to wireframe or GSD workbench to create that profile. We're going to use this bottom profile because this planner is our new face for sketching. So I'm going to select that circular face and sketch. For reference, this is what we are going to create now. We can create one, and then for the other one, we're just going to mirror and mirror again to this side. I can select this and project it as a construction element like that. And then you create the circle. But now this one is a standard element. Its radius. So the diameter is 2. That means the radius is 1 millimeter. And it's a distance of 2.5 millimeters from the center. So the radius is 1. And then the distance, you're going to enter a constraint from the middle to the center. And this is 2.5. Then we've got this tangent line running from the circle to a distance of 0.5 from the vertical axis. You can just select a line. If you zoom in, you can see the automatic constraint definition. So you can see if you start here, as you move it along, it's going to create that tangency. So I'm going to bring it up to that part, and then I'm going to make this point and this circle coincident. Then I'm going to add the 0.5 measurement from the vertical axis. Like so. But now remember, we cannot perform our functions using an open profile like this one. So you can just make another profile of your choosing to just close it up. So perhaps I can just complete it like that. And then you're going to select quick trim this one off, this one as well, like so. But the important part is this part right here. So that will be the one that we're going to cut for this side. So we can make the other sketch by just mirroring this one. So once again, sketch this plane. And then select sketch 3. we're going to project it as a construction element. You can hide sketch 3 and then you're going to mirror. Let's select it first. You're going to select this. You mirror it using the axis. And then select the new profile and then mirror it using the vertical axis. So now the final one is going to be a standard element like that. This one that faces upwards. Okay. So we've got the profiles. Now we need the helix, the center curves. So you can go to mechanical design. There is wireframe and surface design workbench. And from here, you're going to be able to locate the helix. If you don't have the tabs here, you can go to insert, wireframe, helix. All right. Now I don't know if I should create the points first because we need starting points. We need starting points on each extremum. That's the top side. I needed the bottom side. So one is going to be from this side, another one is going to be on this side. But either way, we can just put it roughly because when we're going to be performing our functions, it's going to just we're going to move this profile to the center curve or the center path. We're using height and pitch because that's what we've been given here. We've got a pitch of 25 millimeters and a height of 60 millimeters. Just feed in the values. That's 25, the height is 60. Now the starting point, you can right click and say create a point or create an extremum. Then this is going to be your profile. And then the direction is going to be X component. Say the minimum side. Select OK. The axis is going to be the Z axis because this was right in the middle. If it wasn't in the middle, you would have selected the axis of this particular profile. So in this case, I'm going to select the Z axis. So now the radius of this helix is going to be from the axis you selected to this point, which is the same as the radius of our profile. So if you select, say, font, you can see that the radius is the same as that of the shaft. So that is important to note. If you wanted it to follow a particular path, like let's say you wanted this helix not to go on a straight profile, but rather let's say a bent profile, or maybe we had a profile that looks like that, you would make that curve and then you would select it here as a profile. So you click on profile and select it here. But in this on this occasion, it's the Z axis. So then we're going to select OK. So you can see the distance is up to 60. Then we have a 2mm gap, and then we have 18, adding up to 80mm of the height. We create another helix on the other side as well. The values are the same. This is 25. This is pitch and height. So 25, and then we've got 60. And then the starting point, you're going to create an extremum. Once again, select this bottom circle as your profile. On this X component, the maximum direction. Then the axis is once again the Z axis, and select OK. So we've got both the profiles and the center curves. Let's go back to Part Design Workbench and define this part body as the work object, the current work object. And now we can create the slots. It's as simple as that. So now when it comes to creating the slot, you've got the profile and the center curve. I've already explained. So like you can select sketch 3, and then the profile, the center curve, is going to be the helix that starts there. Now the difference here, we've got profile control. Profile control determines how this profile is going to be winded up your center curve. So in most cases, keep angle is usually the default, and that is because when we are creating slots or ribs, we create them along a planar profile, like let's say a straight line. So keep angle keeps a constant angle between your profile and your center curve. But if you select the drop down menu here, you will see that we have pulling direction, and we also have a reference surface. So for pulling direction, if you select a line or an axis, then it's going to keep a constant angle between your profile and that. No, it's going to be parallel, like your profile here is going to remain parallel to that axis that you have selected, or a plane or a line. And for reference surface, it's going to keep a constant angle between the H direction of your profile. When you're creating the profile, it has a vertical and a horizontal axis. So between the horizontal one, the H axis, and this, the axis of this profile, it's going to keep a constant angle. Now, to understand the differences, for example, in this case, if we use keep angle and say preview, you're going to notice that we are not getting a very regular profile. You see? And that is because our profile, as you can see here, was not like, let's say, a uniform circle. It had some straight line and some curved parts. So when we keep a constant angle between this and the center curve and it's winding, it just cuts at different positions. But if we switch to pulling direction, and let's say select the axis here at the middle, which is the Z axis, and say preview, you see it becomes uniform. Now we've got a uniform cut, and that is because it has kept this profile parallel to that axis that I just selected. So at every given moment, the profile that is cutting is the same at all instances. And also, it's in this case, the pulling direction and the reference surface is going to be the same. Why? Because the axis is the same. If we select reference surface, it's going to select the same axis that we selected when we are saying pulling direction. So if you say reference surface, you're going to select this one. And again, if you preview, it's going to remain uniform. So I hope I have explained that as well as possible, because there's also this option to move profile to path, and that is where, let's say, where you created this where we created this profile is not the same as the starting point of your helix. So if you select move profile to path and say preview, you can see now our positioning has been adjusted. Okay, our position, it has pulled it out up to that point, which is at the very edge. So of course, we're not going to use this one at this case, but there are instances where you want the profile. You create a profile somewhere else and you want it to be just pulled to that point where the center curve is beginning. There is also another option here, which is merge slots ends. So for merging, you're going to have to check where your profile ends. So it ends here, and you can see it's just a sharp cut. So I've specified 60 millimeters. So once the 60 millimeter option was done, that is exactly where it cuts off. So when you select merge slots ends, it's going to extrude this profile to try and merge it with this surface, the top surface. You see, it's going to try and, smooth it out. So mostly when people are creating bolts and such kinds, they select this option for the bottom profile, so that when you're winding, you are not greeted with a sharp cut. So it starts off smoothly and then it winds up. But in this case, there was not that option, so we're going to leave it out. Thick profile or thin slots are the same as when we use pads or other features that are selected here. So instead of creating a block, it kind of selects a thick profile along surface along this profile, or a gap, and then you specify the thickness here. So in this case, we're not going to deal with that. I just wanted to teach you how to select the profile, the center curve, and how to use profile control. So we're going to select OK, and we're going to repeat the same thing for this one. We're going to use reference surface, and then I'm going to select this as our surface, preview, and select OK. So now that's much better. Well, then at the bottom here, we've got chamfer, but for the chamfer, unless we created it before we cut out, we cannot use chamfer. We're going to use a groove. So we've got a 45-degree chamfer. So in this case, I'm just going to create a profile and then select groove, and it's going to cut out our material so that we got a sharp end that is going to drill. You can select the ZX plane and sketch. So select profile and just create a standard profile like a rectangle. Okay. Then we've got the horizontal axis, so I don't need this to merge with the horizontal axis. Just going to do away with this measurement and just add this angle right here to be 45 degrees. And I can just move it like so. So I need this point to not surpass the center because I don't want to reduce the length. So I'm going to add just to make sure like there's a distance there that is being left out, and I'm going to select maybe 0.5. This was not specified, but you can leave out a distance of 0.5 from the middle, and then from here create a 45-degree chamfer. Now exit, and then you're going to select groove around the z-axis. Axis is the z-axis, the profile is sketch 5. All right, so that's the tip of the drill bit, and that's all there is to slots. You can add a steel material. So that's how it looks like. I've selected to show edges and points. You can choose to select material only, and you've got your drill bit. So I hope you enjoyed the video. I intend to keep now teaching you these tools, hopefully one by one, including on GSD Workbench. So let me know in the comments which other tool do you want to learn next. So see you in the next part.